Hey guys, today I'm going to teach you how to solve systems of equations by graphing. By the end of this lesson, you'll be able to graph two linear equations and then find their solution, which remember just means the ordered pair that makes both equations true. So go ahead and get at your binder, turn to the math section. Let's get ready to take some notes. So just to review, a linear equation is just a line. That word line is in the word linear. And in a system of linear equations, we see two or more linear equations or lines that use the same variables. And remember, we graph those in the form y equals mx plus b. That's our slope-intercept form. B is where we begin, and that's always going to be on their y-intercept, and m is how we move, and that's our slope, which is rise over run. So the solution to a system is the point or ordered pair that makes all of the equations in the system true. In a graph, that's going to be the point where they intersect. So when we solve a system, we're always going to end up with a coordinate. This is a coordinate that will make both equations true. So if we substitute in the x and the y value or the coordinate, it will work for both of them. But like we learned last time, sometimes there's examples where there will be no solution or infinitely many solutions. We'll talk about that tomorrow. In all the examples you'll see today, there will be one solution. So let's look at some examples. Let's jump right into it with question 1. It says, use the graph at the right to graph the following equations. So we're going to start with a blue equation and then this red equation. So the first one's going to be blue. I want to begin at the B, and that's always going to be the number that's by itself. That plus 3 means that there is a y-intercept here at 3. And then the slope tells you how to move. So since it's 1 over 2, I go up 1 and over 2 from point to point. So I started here, and I'll count it up 1 over 2. Up 1 over 2 from the next point, up 1 over 2. So that's the pattern that this graph is following. One thing I want to note is that sometimes I get in the habit of just going up and over since it's rise over run, and I know this is a positive slope. But if it's up and over to the right, you can also go down and to the left. So I want to just make sure that we know that you can, if you're going up and over, that the connecting points also go backwards as well. So down and to the left, down 1 over 2 also works. And I just want to do as many points as I can to make a line. That's why I do that both ways. This is roughly what your line's going to look like. So that's the blue line. Now I'm going to graph the red line. One thing I want to notice about the red line is that it looks like that there's no y-intercept. There is a y-intercept, but since it's not written here, there's like an imaginary plus 0 there. This is a proportional relationship since there's nothing being added here. There's no starting point. So I'm just going to make sure that you understand that that goes through 0, 0. That's our very first point since it's proportional. The slope is still next to the x. It's 2. And since it's just a regular number 2, remember every number that's a whole number is just over 1. So 2 over 1 is our slope here. So from this point, 0, 0, I go up 2 over 1. Up 2 over 1. And I do that as many as I can on this graph, up and over, so that I can connect as many points as possible, make a perfect line. If I'm going up and to the right, I also know I can go down and to the left. So down 2 to the left 1, down 2 to the left 1. That works, again, just because down 2 to the left 1. If I'm looking at this mathematically, I know this is a negative divided by a negative, which, as we know, just turns out to be a positive. Negative divided by negative is always positive. That's why that works. I just want to make sure we're clear on that. So down 2 over 1 is the same thing. My line will look something like this. Okay, so this is a review of graphing lines. When we graph a system of equations, we're just graphing two lines. The question is do the graphed lines have any points in common? If so, where? Yes, they do have a point in common. It's right here. And that intersection is the solution to our system. Remember, the solution to a system is always going to be the xy coordinate that works for both equations, or where they intersect. So it's where x marks the spot is what I always like to think. So this point is at 2, 4. Remember, you graph points x comma y. So I went over 2 on the x-axis and then up 4 on the y. So the point where they intersect is at 2, 4. That's the solution to the system. In the space below, I'm going to check and prove that this point works for both these equations just by plugging that point in for the x and the y in each of these equations. So let me just rewrite the blue one. But if you notice, instead of using the y and the x like it was written here, I used this point. This is an xy coordinate. So just like a function, I plug in this number y for the input x. So when I do that, I have all numbers here, so I can actually solve this and simplify it. So half of 2 is 1, plus 3 should equal 4. It does. So this is a true statement. That point works for that line. Let's try it for the other one. And again, I just plugged that point in into this equation. Just substituted the x and the y for the x and the y in the equation. So I got 4 equals 2 times 2. 4 equals 4 is true. So that point works for this equation and this equation. So I've proven it by graphing it, and I found the solution 2, 4. And then I double-checked it and proved it algebraically by substituting that coordinate into each equation and got true statements for both. So that's how you solve systems by graphing. You graph it, and then you can always check it. I've got 3 examples for you to try here. This is an easy, medium, and hard. It says graph the equations below to find the solution to the system of equations, then use the check step to prove that the solution works in both equations. I want you to make sure you're showing all your work. What you can do now is you can pause the video. You can try as many of these as you feel comfortable with. You should definitely be able to do the green. The yellow is a challenge, and then like I said, red is super hard. So only try that if you feel really strong on your algebra. But then go ahead and press play when you're ready to check, and I'm going to go over 3 and 4 and then quickly 5. So go ahead and pause now if you want to try these by yourself, and then press play when you're ready to check. All right, so let's start with number 3. These examples with systems, there's going to be 2 lines, or more even, but in this math, we're going to do 2 lines. So I'm going to always use 2 different colors. I suggest you do the same thing if you can. So I'm going to say that this first line is going to be the purple line, and the second line is going to be the orange line. So the purple line is going to have a y-intercept at 3. So I always am going to plot my B first. Remember that B stands for your y-intercept. It's where you begin graphing. And I'm always going to want to go moving with the slope. So it's down 1 over 2. I know that because there's a negative there. So it's going to have a negative slope. So down 1 and then over to the right 2. Down 1 and over to the right 2. The same thing could be said in the opposite direction. I can go up 1, but I have to go to the left 2. That's because this is a negative slope. So my line's going to look something like this. It's got a negative slope. I know that because I put myself on it. If you're going downhill, has a y-intercept at 3. So that's my purple line. Now I'm going to graph the orange line, which is y equals 5. Remember, when you have a y equals 5, I'm going to go ahead and just make sure you understand. If it's a y equals 5 on the y-axis, it's 5. And it's 5 the whole time. So at any given point on the y line, or on any coordinate, it's going to be a 5 for y. This is a horizontal slope because there's a 0 x's. There's 0 slope. So this is going to be a flat horizontal line. So what I'm looking for is a solution to the equation. The solution to an equation is going to be where they meet. They meet at this point here in red. So that point is at -4, 5. Remember, it's always x, comma, y. Walk before you fly. So -4, 5 is the solution to this system, which means it's just where they intersect. And then I'm going to show you really quickly how I just checked my work. I'm just going to write the equation of the purple line, and then instead of writing an x and a y, I'm going to substitute in the value 5 for y and the -4 for the x, because that's the coordinate that should make this true. So when I do that, I can do my math real quick here. I end up with 5 equals 2 plus 3. 5 equals 5. That's true. So I know that works there. And then when I plug in for the second one, there's no x to plug in. There's only the y. So 5 equals 5. So it works for both equations. You notice all I really needed to do was just graph it and then find that point. And if I'm confident in my graphing, then I don't need to check it like this. This is just to prove it and to check it algebraically to make sure that you understand what you're doing and then a step above what you're doing. Let's look at the mild problem. This I guess was the mild problem. This is the medium problem. Let's look at the harder one. We have 2 equations, so I'm going to use 2 lines. Same way I'm going to do the last one. I'm going to do this one. I'm going to use a purple for the first line and an orange for the second line. So the purple line has a y-intercept at -2. So I'm going to plot my first point at -2. It's going up 1 and over 3. That's my slope. So up 1 over 3. Up 1 over 3. So this is going to be what my line looks like to the right. Again, if I'm going up and over, I can go down and to the left. So down 1 and then to the left 3 will be the same thing. I'm just doing the same points and plotting those points in the opposite direction so I can have a more complete picture of my line. The more points you have graphed, the more accurate your line is going to be drawn. So try to plot as many points as you can before you connect the dots. Your graph should look something like this. Now for the orange one, I'm going to go with B to begin with. So I'm going to begin on the y-axis at 2. And then I want to use my slope of -1, because if there's 1x here, it's -1 over 1, to graph those next points. So I'm going to go down 1 over 1, down 1 over 1. I'm just going to keep doing that in both directions. So if I went down 1 over 1, I'm going to go up 1 over 1. Remember, you want to do as many as you can, even though if you notice, I already found my intersection here. It already touched the purple line, but I want to make this as accurate as possible. So your lines should be straight and they should be as complete as you can make them. So it looks something like this. The point that they intersect is the solution. So it's like where X marks the spot. That here is at 3, -1. Because remember, it's over 3, down 1. That is going to be our solution. It's always going to be an X, Y coordinate. That is where we find our solution. Here is a quick check of my work. I just went in purple because it's the purple line, substituted the X and Y coordinate into the X and Y into the equation, and then just typed it in my calculator real quick and solved it out, and I got -1 equals -1. Since that's true, I know that I did that correctly, and that is a point on that line. That same point should work for the next line because that is the point where they both have in common. That's their solution. So if that works, then when I plug that in on the red line, that would also come out to be true. -1 equals -1. So since it's true on both lines, that's just an algebra way to check that you did your work correctly. Number 5 is a harder problem, so I don't want you to try this one unless you really know how to do it. This is something you could find by graphing on like Desmos or something, but I just want to show you that it's hard because this first line is written in standard form. It's not written in slope-intercept form. So what you would want to do is get the y by itself. So for the purple equation, I'm going to rewrite that in slope-intercept form. I'm going to use this space down here to do that. It's written -6x plus 2y equals -8. Can't do anything until it's written in slope-intercept form. So I'm going to move this -6x first. So I'm using algebra to do that. If it's -6x on one side, it's +6x on the other. And I'm going to divide by 2 to make sure it is written in slope-intercept form. So the new equation for this is going to be y equals -4 plus 3x. Then you can graph, and it'll look like this. Then the orange line, we're going to start at 6 and then go down 2 for every 1. So you can see your solution will be here at 2, 2. So if you got that one done, then you are on a different level because that is using standard form, changing it to slope-intercept form, and then graphing those two lines. So congratulations if you found that solution of 2, 2. And again, if I plugged it in, it would work for both points. But what do you need to know from today? How to graph equations like these two, the green and the yellow problems. Can you graph these two lines and find the point where they intersect? If you can graph a system of equations and you can find their solution. All right, guys, that's it for part 1. If you made it to the end of this video, please comment your favorite number. So today we learned about solving systems by graphing. So now you should be able to graph two linear equations and find their solution, which again, that's just the ordered pair that makes both equations true. That was part 1. Next lesson, we're going to do part 2, and we're going to continue graphing. But for now, you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.